Exertherm condition monitoring system. Okay. This is a infrared IR sensors. This is a cable type sensors. This is an alarm module. Okay, localized, and we got data card inside. Power supply unit. We got the remote system with a SMS capability. Okay. This is a local indication light. This is normal, mode is on. This is warning. This is critical. So the data card is connected. One, other than that is empty. You can able to connect to a data card system. So we set at 15 delta T difference degrees Celsius for warning alarm, and 35 degrees Celsius delta T for critical alarm. And we can see the sensor view, and we only connected to 2. Okay. And you can see from here, we started monitoring the system, and we have simulation with a hot soldering iron. This is a simulation of bus bar with a matte black surface for emissivity itself 0.9. So if it's a reflective, it's 0.2 emissivity. So the distance, it can be from 1 cm to 30 cm away. So now you can see channel 4 is actually for IR TC sensors, and this for cable sensor itself. We are doing a simulation. The as part of this connection means the temperature will rise, so sensors are picking up the delta T difference. It takes a while for it to pick up. For the cable sensor, the conduction will be slower, as it's actually a bit different from infrared, because infrared, whatever hot surface that emits, they will actually receive, and it's a very fast response itself. But the working principle is still the same. Okay, in front is actually infrared, behind is actually a thermocouple, which is they measure the delta T difference. Same like for the cable sensor, there's one here, and behind there's another one here. So you can see here the temperature gradually increase. So once we actually detected abnormality itself, arc flash will not happen immediately. It takes a while according to the NETA standard itself. And for our system, you will not create a false alarm. Okay, it may be some certain times when it's a transient, or there's the spike of voltage, it will hot up the surface, so it will not immediately send any response to prevent false alarm. So you will gradually increase, and see from the channel 3 and 4. So it reaches 13.9 delta T difference. our system will never create any false alarm, as I mentioned. Okay, remember the 15-degree delta T is a warning alarm. So you see, when it's up and when it's down, okay, just now you mentioned, so you won't create a false alarm immediately, because sometimes it may be due to transient for a period of time, then it go down short one. So you won't create any false alarm until the system hold and detect for at least a minute, then the warning alarm will actually activated. Okay, as mentioned, this is to prevent any false alarm. So you hold, so it's quite constant now, consistent, so it's actually detected this is as a loose connection, hotspot. So from the home screen you can see here, there's nothing here, still stable. So when you see alarm, so you can see the data card 1, temperature alarm, so you can go and sensor view, so oh, then you know channel 3 and channel 4 there's a hotspots, and go and rectify it. Okay, at the local panel you will have actually a warning lights. If you have actually remotes, they get another light at your BMS system. Okay, so in order to, when you came down, solve the problem and remove. Okay, even there's still an alarm, you try to clear, you'll never clear until it's actually clear. Okay, you can see here there's a hotspots here still, although we have to clear the channel 4, so channel 3 is still on the hotspot itself. So after you clear the things, you come here, then you click clear, so you'll be clear here locally and at your PMS system or your centralized system. So the whole system has been cleared.